The male engineer, about 25 to 30 years old, stood still in front of the aircraft as if reading a story that had already been written. Beside him, the younger female engineer carefully observed every tiny detail, without missing even the smallest joint line.
The precision on the alignment sequence is remarkable.
Yes, they are well within tolerance for this phase.
In that space, the aircraft was not just a vehicle, but a system that must operate exactly as it was designed. Yet within that certainty, a question began to form in their minds. Why do some designs prioritize absolute reliability,
while others allow change to adapt? Can these two exist together, or are they always in opposition?
and if a choice must be made, what truly matters more in aircraft design? In normal operation, a commercial aircraft is designed to repeat the same behavior thousands of times without change.
Every system from engine to wing is optimized to maintain stability and predictability.
The male engineer inspected each rivet, as if confirming that nothing had changed from the original standard.
Measurements are within tolerance.
Good.
Let's move to the next phase.
In this world, reliability is not just a goal, but the foundation of all design. Every detail is created to behave identically in every flight. There is no room for surprise, because surprise means risk. Aircraft are trusted because they do not change.
And that consistency creates absolute human trust.
But then, another situation begins to form in their minds.
If everything must remain unchanged, how can the aircraft face the unpredictable?
When weather changes suddenly or operating conditions differ from the original design. Can a system that is too rigid respond fast enough?
The female engineer looked at data not just to confirm, but to question its limits.
All readings are within tolerance.
Confirmed. We can sign off on this section.
A subtle tension appears as they realize reliability may come with lack of flexibility. And that creates a conflict that cannot be ignored.
A design that is too stable can become vulnerable under unusual conditions.
The answer begins to emerge as they look deeper into the nature of aircraft design.
Reliability is not rigidity, but the ability to maintain performance within known limits. Adaptability is how a system responds beyond those limits.
Male engineer understands an aircraft cannot change its structure during flight.
But it can be designed to withstand environmental changes without losing control. Backup systems represent adaptability within a reliable structure.
Workers continue with greater attention because every detail contributes to this balance.
Reliability and adaptability do not exclude each other, but complement at different levels. One maintains stability, while the other ensures survival when conditions change. The best design is the one that balances both. In direct comparison, commercial aircraft prioritize reliability because their mission is safe and consistent transport.
Combat aircraft require higher adaptability to respond to rapidly changing environments.
The male engineer sees two design philosophies as different paths toward the same goal.
The female engineer explains that the difference is not which is better, but which is more suitable.
Workers continue, but now understand the meaning behind each action. As the data shows, we can't achieve extreme stability and extreme flexibility at the same level.
Every choice has a cost, and design is the acceptance of that trade-off.
Reliability brings assurance, but limits change.
Adaptability brings flexibility, but requires more complex control.
The balance point is critical for this configuration. Yes, I've updated the calculations on the tablet. It looks optimized now.
In the end, the question is not choosing one, but understanding how they coexist. Reliability builds the foundation of trust in aircraft.
Adaptability ensures that trust remains when conditions change.
The African-American female engineer closes the data record, feeling every number now has meaning.
Look at the uniformity of the polish. The thermal signature will be optimized. Indeed, this level of precision exceeds the projected metrics.
The aircraft remains unchanged, but their perception has shifted.
Design is no longer about right or wrong, but about finding balance. In aviation, that balance defines success.
Because a good aircraft is not only stable, but able to survive when reality changes.